Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairul Nizam bin Ibrahim, 11 DK 1055 in my metric number, and me and other two friends Tamiz and Shauki will present about chapter 3 fluid mechanics. The title is Hydrodynamic.
Hi, my name is Ahmad Roshauki bin Ahmad Fazil. My metric number is 11 DKA 20F1044. My class is DKA 3A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Tarmizi bin Abdul Razak. My register number is 11DKA20F1041.
So the first is ideal fluid flow and real fluid flow. So the first ideal fluid flow is non-viscous and incompressible. Shear force between the boundary surface and fluid is absent, and only pressure force and body force are controlling. And next, for the real fluid flow, real fluid have viscosity and surface shear force are involved during flow. The result of other fluid flow analysis are found applicable in the study of flow of real fluid when viscosity values are small. For the next slide, we can see about compressible and incompressible flow. So the fluid has an incompressible flow, which is the density of the flowing fluid is constant during the process of flow. So next, the compressible flow is the density of fluid does not remain constant during the process of flow. In other words, the density of the fluid change from point to point in compressible flow. Before we go to the what is added fluid, real fluid, and any more about chapter 3 hydrodynamic, I want to introduce about what is hydrodynamic definitively. So the first is fluid or flow can be classified based on the motion of the fluid particles. Fluid motion, which is characterized by the random and irregular movement of the fluid particle, is classified as turbulent flow. The movement of the fluid particles in turbulent flow is also accompanied by small fluctuation in pressure. Typical example of turbulent flow include a hydraulic jump from a spillway, flow in fast flowing river, and smart dispersal into the atmosphere from stacks. Flow characterized by orderly movement of fluid particle in well-defined path is classified as laminar flow. Fluid in laminar flow tends to move in layer. Flow of highly viscous fluid tends to be laminar. Flow of given fluid may change from laminar to turbulent if the velocity of the fluid is increased beyond certain limit. So we have three general type of fluid flow in pipes. The first is laminar flow, transitional flow, and turbulent flow, which can be explained more with my friend in next slide.
Next, uniform flow and non-uniform flow. Uniform flow, the velocity at the instant of the time is same at both magnitude and direction in the same flow. When the velocity is changes from point to point and at any instant of the direction, the flow can be described as non-uniform flow. A steady flow is one has condition of pressure, velocity, and cross-section may differ from point to point but had no change at the time, while the unsteady flow has different at the condition and it change the time. Term 1 to 3-dimensional flow refer to number space coordinate required to describe a flow. So we have 1-dimensional flow, 2-dimensional flow, and 3-dimensional flow. An open system let both energy and mass transferred through their boundaries. For example, a cup of coffee are open, so both energy and mass are transferred out through the air. Secondly, the closed system. Closed system only allow energy to be transferred but not transferred of mass. For example, a cup of coffee has lid on it. It's only transferred the heat but not let the mass reduce.
Okay, the definition for Reynolds number is used to determine whether the flow is turbulent or laminar. For the purpose to get some sense of the relationship in fluid flow between initial forces, that is those that keep going by Newton's first law. An object in motion remains in motion, and viscous forces, that is those that cause the fluid to come to a stop because of the viscosity of the fluid. There are in general three types of fluid flow in pipes. First one is laminar flow. Number 2, transitional flow. Number 3, turbulent flow. Okay, the first one, laminar flow. Laminar flow generally happens when dealing with small pipes and low flow velocities. Laminar flow can be regarded as a series of liquid cylinders in the pipe, where the innermost parts of flow the fastest and the cylinder touching the pipe isn't moving at all. Shear stress depends almost only on the viscosity and is independent of density. Number 2, transitional flow. Transitional flow is a mixture of laminar and turbulent flow, with turbulence in the center of the pipe and laminar flow near the edge. Each of these flows behave in different manners in terms of their frictional energy loss while flowing, and have different equations that predict their behavior. Turbulent or laminar flow is determined by the dimensionless Reynolds number. Number 3 is turbulent flow. Turbulent flow happens in general at high flow rates and with larger pipes. Shear stress for turbulent flow is a function of this density. Okay, the Reynolds number is important in analyzing any type of flow when there is substantial velocity gradient. It indicates the relative significance of the viscous effects compared to the inertial effect. The Reynolds number is proportional to inertial force divided by viscous force. Okay, let's go to the example. A liquid flow in the pipe of 30 cm diameter and with the velocity of 0.21 meter per second. Calculate the Reynolds number and types of flow if the kinematic viscosity equal to 1.14 millimeter square per second. Okay, the solution is first, the diameter, we must convert it from centimeter to meter. 30 centimeter is equal to 0.3 meter. Okay, and the Reynolds number formula is equal to VD over V, which is V, the velocity multiplied to diameter over divided by kinematic viscosity. Okay, 0.21 multiply 0.3 divided by 1.14 multiply 10 the power of negative 6. The answer is 55,263, which is more than 4,500. So, the types of flow is turbulent because the Reynolds number is more than 4,500. That's it for me. Thank you.